Welcome back to AI Edge Daily. I'm your host, and today we're breaking down a story that's reshaping the AI landscape in 2026. Z.ai just released GLM-5.2, and it's doing something we haven't seen in a while, beating OpenAI's GPT-5.5 on multiple long-horizon coding benchmarks while costing just a fraction of what you'd pay for the closed-source alternative. This is a huge moment for OpenAI's AI, and we need to talk about what it means. Let's start with the headline numbers because they're genuinely impressive. GLM-5.2 is outperforming GPT-5.5 on several of the most challenging long-horizon coding benchmarks. We're talking about complex, multi-step programming tasks that require sustained reasoning, context management, and deep technical understanding. These aren't simple function completions. These are the kinds of problems that separate truly capable AI systems from those that can handle simple queries. But here's what makes this story even more compelling. GLM 5.2 is an open weights model. That means researchers, developers, and companies can download it, inspect it, fine-tune it, and deploy it however they want. There's no API gatekeeping. There's no rate limiting. There's no vendor lock-in. And it achieves all of this while costing approximately 1/6 the price of GPT 5.5. Let me break down why this matters. For years, the narrative around large language models has been dominated by a few closed-source players. OpenAI, Anthropic, Google, these companies have pushed the frontier of what's possible, and they've done valuable work. But the cost structure has always been a constraint. Running GPT 5.5 at scale is expensive. You're paying premium pricing for access to a model you can't modify, inspect, or truly understand. GLM 5.2 changes the economics entirely. If you're a development team, a research institution, or an enterprise deploying AI at scale, the financial case for using an open weights model that performs better on your core benchmarks is becoming irresistible. We're not just talking about marginal improvements here. We're talking about beating the supposed state-of-the-art on some of the most difficult tasks in AI evaluation. Let's dig into what long-horizon coding benchmarks actually measure. These aren't your typical human eval-style benchmarks where the model completes a function in 50 lines of code. Long-horizon tasks require the model to work through complex, multi-part problems. They demand sustained attention, logical consistency across dozens or hundreds of steps, and the ability to reason about program structure at a high level. They measure whether an AI system can actually be useful for real software engineering work. The fact that GLM 5.2 is winning here is significant. It suggests that the architectural decisions and training approaches Z.ai has taken are genuinely well suited for the kinds of reasoning and planning that long-horizon tasks demand. This isn't a narrow win on a single benchmark. This is a broad capability advantage across multiple challenging evaluations. Now, let's talk about cost. 1/6 the price is a meaningful difference, and it's compounding when you think about real-world deployment. If you're running inference on millions of coding tasks monthly, the savings add up to